Hey guys, today we're finally getting into something that I think is going to be new for most of you. We're going to be multiplying and dividing powers, and in order to do that, we're going to be using something called the exponent laws or exponent rules. There are actually 5 different exponent rules. We're going to be going over the first 3 of those today. We'll go over the next 2 tomorrow. So let's get into it. Okay, so this is lesson 2.4, multiplying and dividing powers. The first thing I want to remind you of when we talked about this in the last lesson is that if a term has no exponent, it actually has an invisible 1 as an exponent. And that can become very important. Okay, so like I said, there are 5 exponent rules or exponent laws. Today we're going to be going over the first 3 of them. So the first one says that if we are multiplying powers, so these are 2 powers, if we are multiplying powers with the same base, then we take their exponents and just add them. So we just rewrite the base and add their 2 exponents together. If we are dividing powers with the same base, we take their exponents and subtract them. So again, just rewrite the base, subtract their exponents. And then the last law that we're going to be looking at today is if you have an exponent on the outside of a set of brackets containing a power. This is called the power of a power. So I am taking the power of another power. What we do in that case is multiply the 2 exponents together. Since, as you may have noticed with the division as well as the multiplication, this only works if the bases are the same. So sometimes if you're asked to multiply or divide, you may need to rewrite the power to get a common base before you can use any of these laws. So let's go through a couple examples of what this would look like. Okay, so for the first example here, I'm actually combining all 3 of those laws. On the top here, we have that power of a power situation. On the bottom here, I'm taking an x and I'm multiplying it by an x cubed. And then of course, I also have this division that's happening here. So let's go through how we would solve this. The first thing that I would do is I would solve the top here, and when I have an exponent, like this 4 here, that is applying to another power, I multiply those exponents. So on the top there, I would end up with x to the power of 8. And then on the bottom of this, just remember, if I have a power or a term with no exponent, there's actually an invisible 1 there. And now that I have 2 powers with the same base and I'm multiplying them, I add their exponents. So on the bottom, I'm going to have x to the power of 4, since it's 1 plus 3. And then my last step is to deal with this division that is taking place here. So x to the power of 8 divided by x to the power of 4. And when we have that, we just keep our base and we subtract the exponents. So 8 minus 4 is, of course, 4. And that would be my final answer. Okay, the second example here, I'm going to show you how to find a common base. So just remember, we can't use any of these exponent laws if our bases aren't all the same. And so what we're going to be doing here is simplifying, not solving. We're just going to simplify this expression. And in order to do that, our first step needs to be to turn this 8 into 2 to the power of something, since our other 2 bases are both 2's. So what I'm going to do is I'm going to say, so let me just write out the rest of it. I'm going to say 2 to the power of what can give me 8. And if you're not sure, if you don't just know that 2 to the power of 3 will give you 8, what you can do is in your calculator, just start by doing 2 to the power of 2 and seeing what you get. It'll be 4, and then go up from there. So your next one that you should try is 2 to the power of 3, which would give you 8. So I can replace that 8 with 2 to the power of 3, since 2 to the power of 3 is equal to 8. Now I can start solving this thing. So because I have 2 to the power of 3 and 2 to the power of an invisible 1, I can start by simplifying that. So when I'm multiplying like bases, I just add the exponents. And that's still all squared, and it's over 2 to the power of 4. My next step is going to be to apply this exponent to my power. When I do that, I multiply the power, so that's 2 to the power of 8 over 2 to the power of 4. And now my last step, now that I'm dividing like bases, I subtract their exponents. So my final answer will be 2 to the power of 8 minus 4 is 4. And that's it. Okay, so this is what it looks like if we simplify. If it asks you to solve, you would actually plug 2 to the power of 4 into your calculator and see what that is, or in your head do 2 times 2 times 2 times 2 and get 16 would be actually solving this. Okay, but a lot of the time it's going to ask you to write it as a power with a single base or to simplify, which is going to look like this. Okay, let me know if you have any questions.